Okay, so we're in section 5.3. Like I said just a moment ago, I'm assuming you've had intermediate algebra either here or high school, wherever you were. So you've seen 75% of what we're going to talk about today. So what we're going to do is just do a reminder of how to solve equations that have fractions in them. And we're going to do a few problems, and then we'll do the new stuff. And the new stuff is just the last couple problems at the bottom, and then the pictures on the back page, which are solving inequalities that involve our rationals. And then I have a review problem at the very end. If there's time, there should be time. This is not a super long section. If there's time at the end, we'll practice a graph of the x minus 6 over x plus 2. So that's where we're going today. If you have any questions, let me know as we go through. I want to be helpful. I want you to do amazing. I know that this is a difficult unit. I get we don't like fractions. So please interact with me as you need to. And hopefully we'll get through this together. So this is section 5.3. And what we're going to do is we're going to solve rational equations and inequalities. In fact, I mentioned when we were graphing that when we had to determine if a graph goes through its horizontal asymptote, we had to solve a kind of a mild rational equation. And I had said, I wish we did this. I probably should just go ahead and reverse the order myself. There's no reason I couldn't. So here we go. So we're going to solve this. This is example 1. And it is this, x plus 2 over 2x plus 1 equals 1. And this is a nice, relaxing example. We're going to use this equation when we get down to the bottom. We're going to use this to solve the inequality. We've talked about solving inequalities with respect to quadratics. And I told you the procedure there is the same procedure we're going to employ every time we encounter any sort of inequality. But before we get there, I want to solve this equation. So I don't want to have a fraction anymore. And so I want to clear the fractions like we've been doing since the first day of class. But now we have variables in the bottom. So we multiply by the common denominator. This is a nice relaxing problem. It only has one fraction. What's the common denominator in this problem? 2x plus 1. Yeah. So I'm going to multiply every term by the 2x plus 1. So over on the left, I'm going to multiply by 2x plus 1. And over on the right, I'm going to multiply by the 2x plus 1. So if you can understand the general procedure on this simpler style problem, and remember, simple isn't easy. Simple just means fewer steps. This simpler style problem, then when we get to the next couple problems, it's the same premise. So on the left, notice my 2x plus 1's cancel. That's why I multiply by the common denominator. So what remains on the left of this problem? Yeah, there's nothing else. There's nothing to multiply by. It's just x plus 2. On the right, please don't forget to distribute. That's probably the most common mistake students make on these problems. So in this case, it's a 1. So I gave that injunction, and there's no payoff here. So 1 times 2x is 2x. 1 times 1 is 1. Have I lost anybody yet? We good so far? All right, now this, hopefully we can just whip through this. We've been solving linear equations since birth, it seems like, as far as algebra goes. So I'm going to put all my x's on the left, all my numbers on the right, and then I'm going to divide. So I like my x's on the left. If you want to move your x's to the right, that's your prerogative. Do whatever makes you happy. So when I subtract the 2x from both sides, I get a negative x over here. When I subtract the 2 from both sides, I get a negative 1. If you brought the x over to the right, then you have a 1x over here. And then if you brought the 1 over to the left, you're solved. You have one fewer step. So it's probably smarter to do that. I'm going to divide both sides by negative 1, and I get x is equal to 1. Now, before I can go away happy, it doesn't happen on this problem, but I'm going to mention it so that you don't think it comes out of the blue in just a moment. We always have to be aware that our fractions have a limited domain. Okay, there's a break in the domain of our fractions. So you always have to test this. Okay, we always have to test and make sure that the denominator is not made 0. If my potential solution here makes the denominator 0, then I throw it out. If my potential solution here does not make the denominator 0, then I keep it. I love it. So I'm going to take the value 1. When I put 1 in, what's 2 times 1? Thank you for being awake. 2 times 1 is 2, plus 1 is 3. So that is good. It doesn't make my denominator 0. So I can throw that now into my solution set. And there's my solution to the equation. Don't forget to do that. That's going to happen on not your first example. Your first example is going to be a nice, relaxing problem like this. But then when we get to the next ones, some of those we will have to be very cautious with the potential solutions we get. So here's one for you. I would like you to please do this problem right here. Exercise 1. Same sort of thing. Solve that equation, please. Just to make sure we're all moving in the same direction. What is the common denominator that I'm hoping you multiplied both sides by? Okay, keep going. Great, thank you. X plus 2. It's the only denominator, so I'm hoping that that's fairly apparent. Okay, I'm going to get started. If you're working, keep working. Check your answer with mine. I'm going to do just what you said. I'm going to multiply both sides of this by x plus 2. There it is. So on the left, everything cancels, and I'm just left with the x minus 6. Any concerns about what you have on the left side of this? On the right, I'm going to take the negative 1 times that. So a negative times a positive x, negative x. A negative times a positive 2 is negative 2. We good? That's the hard step. Okay, from here on out, I'm hoping this is just routine for you, solving the equation. I'm going to bring the x over to the left by adding it, so I get 2x. I'm going to bring the 6 over to the right by adding it, and so I end up with 4. Divide both sides by 2, I get x is 2. And then hopefully you checked that answer just to get in the habit of doing it. And when I put 2 in, 2 plus 2 is 4. That's legitimate. Great. So here's my solution set. So that's the simpler style problem. Any concerns yet? Hopefully this is coming back from your long repressed memories, maybe some bad algebra memories. Maybe things are better now. All right, so I'm going to do another example, and then I've got 2 or 3 that you're going to do. So this is my example 2. It says this. I've got x over x minus 2 plus 1 over x plus 2 is equal to 8 x squared minus 4. All right, we are ready to rumble. Again, the premise that we're going to follow here is the same as the last problem, but it's a little more complicated. I've got 3 fractions instead of just 1, so we have to proceed with caution. So the first thing I have to do is I have to figure out the common denominator. In order to figure out the common denominator, everything has to be factored so that I can see all the individual factors. Which one of those denominators, there's only one, which one of those denominators do I need to address with some factoring? Yeah, the x squared minus 4. Okay, the x minus 2, x plus 2, those are factored. In fact, the x squared minus 4, we're going to see some commonality here. How does x squared minus 4, it's a difference of squares, how does that factor for us? X minus 2, x plus 2. I mentioned this before, I'll say it again. Okay, while I'm not going to expect too terribly difficult factoring in here, you need any sort of review, let me know. I've got all sorts of intermediate algebra videos. I can share links, and you can see even more of the perkster, okay, when you're not in class, because I know everybody wants more. So here we go, x plus 2, x minus 2. Difference of squares. Make sure those signs are different. So the common denominator, again, I'm hoping I'm refreshing your memory. The common denominator in something like this is basically you take one of every factor you see, and if you have a power, you take the highest power. Okay, so if you don't remember that, that's the summary. One of every factor you see, and if there's a power, you take the highest power. So if that is my instruction, what is the common denominator going to be of this? If I need one of every factor I see, give me a factor. Okay, yes, everybody is really shy today. That's fine. X plus 2. Great. I'm feeling great, though. I had a full Diet Coke. I'm filled with energy right now. I'm right. So just keep talking. What's the other factor we need? There you go. More voices. I love it. Thank you for attending today. There's no other factors. I don't have any powers. There's no squares. There's no cubes. I only need to include one of each because none of these denominators has more than one. There's 1x minus 2 here. There's 1x plus 2 here. There's one of each here. Okay, so I don't need squares. I don't need cubes. You with me so far? All right, so now what I'm going to do is I'm going to take each of these three fractions and I'm going to multiply it by x plus 2 times x minus 2. Okay, so this first one, x plus 2, x minus 2. I've got to squeeze it in here because I never think ahead. You'd think after all these years of teaching, I would think ahead, but I'm not that smart of a person. X plus 2, x minus 2, I'm squeezing it in. And this fraction right here, x plus 2, x minus 2. I multiply every term by x plus 2, x minus 2. Anybody, have I lost anybody? Do you see what I've done with that common denominator? Are we okay? No reason not to speak. Other than I know you're probably tired. I know it's 9:15 and we're doing algebra and that there's something wrong with that. Okay, the first fraction. What happens on the first fraction? What cancels? The x minus 2's, goodbye. Remember, if you've done this right, every fraction should go away. You should have no more fractions. Don't forget to distribute. I'm going to do this all in one step. If you're bothered by it, let me know. X times x is x squared. X times 2 is 2x. The next term, what cancels in this fraction? The x plus 2's, yes. So I have 1 times x minus 2. Well, 1 times anything, that's just going to be x minus 2. And then on the other side, here's the payoff. What cancels over on this side? Everything. It's a canceling party. Goodbye. And what am I left with on the right side of the equation? 8. There you go. Again, that's the hard part to the problem. Getting to that, I understand. Fractions are laborious. Okay, this is a quadratic equation. I know it's a quadratic equation because of the x squared, so I have to get everything on the same side. Okay, we don't separate the sides on a quadratic. So I've got x squared, 2x plus x, that's 3x. And when I subtract the 8 and bring it over, I have negative 10. Once again, I will repeat, at this point, you are welcome to use the quadratic formula. It works no matter what. I see that this is going to factor, so I'm going to factor it. We will end up with the same answers, and either way, it doesn't matter. X squared, the factors of x squared are x and x, and then the two factors of negative 10 that are going to add up to positive 3 are plus 5 and negative 2. And if you need factoring help, there's no shame in needing help and asking for help. I just need you to ask. I don't read minds. So now I'm going to subtract 5. The first potential solution is negative 5. I'm going to add 2. The next potential solution is positive 2. But as I mentioned, when I look at both of those solutions, I do on this problem have to throw one of them out. Which one do I have to throw out? Why am I throwing out the positive 2? You're 100% right. 2 minus 2, when I plug it back in here, 2 minus 2 is 0. It's not in the domain of my original fraction, So that one gets thrown out. There'll be some problems that you keep both answers. There'll be some that you throw one out. There'll be some that you throw both out. Okay, it just depends on the problem. You have to check. So my solution set then is simply the set with -5 in it. That one is fine. So the next couple problems that are on the sheet are just variations of this same theme for you to work through. So going to give you 2 or 3 minutes. Exercise 2, right next door. If you have a question, anything that I am not doing a good job clarifying for you, please let me know. I am happy to try to help you be better. Again, I'm not ready to work the problem. I just want to make sure we're all going the same direction. This first fraction's denominator, the 4x squared minus 1, that is a difference of squares. So 4x squared is 2x and 2x, and then plus 1 minus 1. So here's just what I wanted to ask you. Make sure we're all doing the same thing. What is the least common denominator that you are multiplying all 3 fractions by? Just one of each. Yes. 2x minus 1, 2x plus 1. Great job. Okay, hopefully more of you had that than I heard voices. I'm assuming that's true. If not, let me know. All right, 2x plus 1, 2x minus 1. I see a lot of you sitting, so either you're not knowing what's going on at all, or you're done and you're just waiting for me. So let's do this. 2x plus 1, 2x minus 1. We do it right here again, squeezing it in. 2x plus 1, 2x minus 1. So now we'll go through, we'll get rid of these fractions, and then we'll be ready to solve the problem. So first fraction, the 2x plus 1 and the 2x minus 1 both cancel, just leaves me with this 8x. There's my first fraction gone. The second one, the 2x plus 1's cancel. So I have 3 times 2x minus 1. 3 times 2x is 6x. 3 times -1 is -3. And then finally, the 2x minus 1's cancel. And so 3 times 2x is 6x. 3 times 1 is 3. I'm going to stop here. That's the most difficult part for this problem. Does anyone have a question, concern, anything that's not apparent from this? Okay, there's no reason not to speak. We are not in a rush today. So I hope that you're just not withholding because you want to get out of here early. That's not going to happen. 6x is 12x. Negative 3 plus 3, that cancels. That's just happenstance. So again, this is a linear equation. Don't worry, we've got x's here, so this is not a contradiction or anything like that. I'm going to put all my x's on one side, and then I don't have any numbers, and so I'm going to subtract the 12x. Sometimes this throws students for a loop. That's why I'm writing out the step. 8x minus 12x is negative 4x. Then on the other side, 12x minus 12x, what does that leave me? 0. That's a number. Okay, so 0. I'm going to put that there. Again, not a contradiction. I still have an x. Remember, contradictions and identities only happen when the x's go away. Okay, and that's not what's happened here. So then I divide by negative 4, and 0 divided by anything is just going to be 0. That's my answer. Does 0 make any of these denominators 0? Do I have to throw it out? Nope. Makes this denominator negative 1, this one positive 1, it makes this one negative 1. So that's all fine. So my solution set is 0. We're just going to repeat this process 2 more times, okay, just to make sure that it's sinking in and that you're where I need you to be. So if there's a question, please, I beg for questions. Do exercise 3. Same sort of thing. I factored this last denominator. t plus 7, t minus 7. So step number 1, what is the least common denominator of this problem right here? What are we going to use? Sure. Most of the problems you do, it's going to be just staring you right in the face what the common denominator is. Okay, it's just one of everything, and then if there's powers, you take the highest power of whatever it is. So I'm going to multiply everything by t plus 7, t minus 7. So one right here, one right here. Now I'm ready to get rid of my fractions. So the first one, t minus 7's cancel. What's left when I do that? 1 times t plus 7 is t plus 7. Great. The second one, the t plus 7's cancel. What's left there? Okay, 2 times t minus 7, and others of you I heard already distributed it. So 2 times t is 2t. 2 times negative 7 is negative 14. Still good? And then over here, everything cancels. And so what's left on the right side of this? There it is. So I've just got a linear equation. It's not there's no square here, so I don't have to get everything on one side. So t plus 2t, that's 3. 7 minus 14 is negative 7. I'm going to add the 7 to both sides. I'm going to divide both sides by 3. And the solution is t equals 7. Anybody, I'm not writing the steps. Are we okay with that? Everybody see what I've done here? You know how to solve a linear equation? Don't be shy. There's no shame in saying, please write the steps, Perkster. Don't be lazy. Okay, so now what's the problem with the 7 though? I get a 0 right here in this denominator. 7 minus 7 is 0. So what do I do with this? Throw it out. Goodbye. Seems like it was all for nothing. What's the solution set? Empty set. Remember, pick your favorite symbol. I like the squigglies with nothing in between them. If you use the null symbol, don't put squigglies around it. Okay, if you do this, that's technically wrong. Okay, you're trying to give me too much information there. All right, last one of the solving, exercise 4. Go for it. Just because these denominators are a little different, I just want to address this up front. What's the least common denominator of this problem right here? What's the only factor I see? An x. Okay, and my instruction was, you take one of every factor, x, and then what if there's powers? What do we do when there's a power? The highest power. So my common denominator is x to the second. Okay, so there you go. If you're struggling with that, it's one of everything that you see. So this is an x, this is an x, same thing, and then the highest power. So x squared. Okay, keep going. If you didn't get that right, that's all right. You're learning. Mistakes give you the chance to learn. I'm going to multiply everything here by x squared. So multiply the 4 by x squared. 7 over x by x squared. The negative 1 over x squared, I multiply it by x squared. Okay, every term gets multiplied by that common denominator because my goal is to clear the fractions. So here goes my first term, no fraction to clear. So it becomes 4x squared. Again, second most common mistake on these problems after not distributing, like on a problem like this with this 2. The second most common mistake is forgetting when I have a term that's not a fraction to also multiply it by the common denominator. Okay, so if you did that, okay, just circle it and remind yourself that you multiply everything by the common denominator, whether it's a fraction or not. Okay, and then the next one, I've got an x in the bottom, an x squared in the top, so this x cancels with one of those, and I'm left with what? 7x. And then equals over here, the x's both, or excuse me, the x squareds both cancel, and it leaves me with negative 1. So this is a quadratic equation. I've got my x squared. So whenever I have a quadratic equation, that means get everything on the same side. So I will add that 1 over. I don't think this one's going to factor for me. So if you try to factor, I understand why. But there's going to be no factors of 4 in combination with 1 that are going to add up to 7 as far as I can see. So we're going to have to use the quadratic formula on this problem. So good reminder of that. So my quadratic formula says negative b. What's the value of b of this quadratic equation? Okay, so it's negative 7 plus or minus square root of b squared. So 7 squared is 49. If I put a value down that you don't understand where or why it came from, that is an opportunity for you to ask a question. Okay, so minus 4 times a, what's the value of a of this quadratic equation? 4. And then times c, what's the value of c of this quadratic equation? 1, yes? All of that over 2a, so 2 times 4, you can write down 8, but I don't want to skip too many steps just in case you're struggling to keep up. In which case, I would hope you'd say, hey, Kirk's struggling to keep up. All right, so I'm just going to move this up here so everybody can see. So negative 7 plus or minus. Underneath my radical, I have 1 times 4 is 4. 4 times negative 4 is negative 16. So that's 49 minus 16, or maybe you've already written down 33. Does 33 have a perfect square factor? Can I simplify that radical in any way? Nope. 33 is 3 times 11. Those are both prime numbers. Prime numbers are lovely, but unfortunately not good for taking square roots. Okay, so can't do anything with that. There's your 2 answers. Clearly, neither of these are going to make the denominator 0. What's the only value, if I had gotten it as a solution, that's going to make my denominator 0? 0. Okay, that's not either of these. These are some decimal. I don't care what the decimal is. I am done, and I'm just going to be super lazy. I'm going to just throw some squigglies around that. That's my solution set, both of those values. So not everything has to turn out to be a nice whole number or an integer. You'll see that a lot because I'm not trying to torture you more than you feel like you already are being. But I just wanted to show you that you can get any answer to these problems. That's my kind of run through of solving rational equations. Hopefully most of that was review for you. Again, if it's not, I have some videos from my intermediate algebra class that I can share with you with more examples that you can do. Is there a question before we move on to inequalities? All right, the next example. We each got just one inequality. Once you can solve an equation, you can solve an inequality. There's pretty much no new skills. It's just the combination of things that you already know how to do, I'm hoping. So I'm just going to remind you. Here's the process that I'm trying to implore upon you to solve an inequality. Okay, we first did this with quadratics. We're going to do it here with rationals. On Monday's lesson, you're going to do, no, not Monday's lesson, Wednesday's lesson next week, we're going to do this with radical equations, okay, and then it's going to come up again in a future section. So this same process is going to be used over and over. This is already in your notes when we solved quadratic inequalities. The first step is to solve the equation. So for our example 3, we have x plus 2 over 2x plus 1, and that is less than or equal to 1. Well, the good news is I've saved us a little work here because up above at the very beginning, we've already solved the equation. Okay, we've solved 6 equations. So whatever inequality you had, if it was based on one of these, we've already done the first step. Remind me, because my short-term memory is going, because I'm getting old, what is the solution to example 1 when we did it? 1? Okay, so step 1, just going to put over here, the solution set is 1. We got that from the very first problem. Okay, just kind of saving a little work. Everybody with me on where this came from? That should be on your notes, the very top. Step 2, again, this is in your notes, but on a previous worksheet if you're still carrying those around. Okay, the second thing that you do is you use a number line to represent the domain. Now, when we did this with quadratics, the domain of a quadratic equation, an x squared, is negative infinity to positive infinity. So we used the whole number line. But now, for the first time, we're going to do an inequality that has a little bit of a differ in that. So I'm going to draw my number line from negative infinity to positive infinity. So again, we're just drawing on things that you already know how to do, and we're adding them to this stew of solving an inequality. We know how to find the domain. We talked about it in terms of finding the vertical asymptotes. Where do the vertical asymptotes, meaning the x values that I can't use, the x values the graph is never going to go through, where do those happen? What about the denominator? Yes, when the denominator is 0, that's a problem with the domain. That's where we have a vertical asymptote. Okay, so I'm going to take this 2x plus 1, and this is step 2 right here. I'm going to take this 2x plus 1, and I'm going to set it equal to 0. I'm going to say, where does that happen? Where does that vertical asymptote happen? So I'm going to subtract 1, divide by 2, and we get negative 1/2. Now, on my number line, here's how I notate that, because I don't want to accidentally think that this is a possible solution. Okay, so if there's one thing, if you have not listened to me at all this morning, I don't blame you. Okay, I can't stand the sound of my own voice. This is the one thing, though, I would invite you to please listen to. When you're making your number line and you're labeling it, and we're going to put negative 1/2 on here, to remind yourself that that is not an end point. Okay, that's not going to be a solution. That is a problem. I would recommend drawing a dotted line here to remind yourself that that's an asymptote. Okay, that's an x value that's never going to be part of your graph or your solution set. Okay, that's a problem with the domain. You tracking with me on that? All right. Then the other thing I'm going to put on my number line is where it's equal. That happens at 1. So again, the reason I put a dotted line here is I don't want you to think that this is a point of equality. This is a point of problem. It's the fraction does not exist there. So far, so good? And then the last thing, okay? So first thing we did, we solved the equation. The second thing is we use a number line to represent the domain. And then the third thing and the last is we test each interval. Now I know with the quadratics, the test was easy because quadratics pretty much just alternated. Once you tested the first interval, you could then predict. But now rationals do not have to alternate. The simpler ones probably will, but the more complicated ones won't. So you have to test each interval. So we're going to pick a value in each interval, and we're going to see, does it give me a true statement or a false statement? Is it less than 1 or is it greater than 1? That's going to be our question. So in this first interval, what's a value in this first interval that we could plug in? -2 sounds like a perfect value. -10, -100, whatever makes you happy. Anything less than -0.5. So I'm going to plug -2 in up here. If you got a calculator, you might want to help me. And the question we're going to ask is, when I plug -2 into this, do I get something that's less than 1 or do I get something that's bigger than 1? It's going to be one of the two. And I know it's going to be one of the two because the only point of equality is over here. So we're not going to get equals. All right, here we go, -2. When I put -2 up here in the top, I get -2 plus 2. In the bottom, 2 times -2 is -4 plus 1. Well, this is fun. Good pick. -2 plus 2 is 0. -4 plus 1 is -3. What's 0 divided by -3 equal to? 0. So here's the question. I just got 0 right here. Is 0 less than 1 or is 0 bigger than 1? It's less than, so I'm going to put a less than right there. Let me stop, because I remember when I graded the tests and I put a couple quadratic inequalities, there was some stumbling around on this point. Okay, so I think some people didn't quite understand what's going on here, what I'm doing. So now's the time. What if this is confusing you, what about this? Help me understand how I can explain this better. Does anyone not see why this is a less than here, where that conclusion came from? Are we okay? If you're not okay, please speak. I think I'm a fairly friendly guy. I'm not going to get mad. Okay, I don't think I'm perfect at explaining things. Okay. I'm going to keep moving on. If you have anything, just raise your hand. Okay. What's a number to test in between these two right here? 0. Yes, my favorite. I'm glad you picked that. Instead of picking 0.5 or 0.75, that would be, you can do that, okay, but that's a little bit of a struggle there. So when I plug 0 in, 0 plus 2 is in the top. In the bottom, 2 times 0 is 0 plus 1 in the bottom. So I get 2 over 1, and 2 over 1 is 2. So I got 2 right here. So is 2 bigger than 1, or is 2 less than 1? Bigger, so I'm going to put a greater than right there. Again, I do have to check. I know you don't want to, but rational functions can just bounce off the x-axis, so we could get a bigger over here. So I do need to check. It's probably not going to happen on this one, but I do want you prepared. So what's a value in this interval that I can plug in? 2, sure. Anything bigger than 1, 10, 100, a billion, if you really feel like it, that's fine. So in the top, we have 2 plus 2. In the bottom, 2 times 2 is 4, 4 plus 1. 2 plus 2 is 4, 4 plus 1 is 5, so I get 4/5. Your calculator will tell you 4/5 is 0.8. So is 0.8, I got 0.8 right here. Is 0.8 less than 1 or is 0.8 bigger than 1? Before we do the answer to this problem, does anyone not see, did I confound anybody with any of these conclusions? So then I'm just going to erase these right here. I don't need these bits anymore. And now we're going to answer the question. So now, where is this fraction less than or equal to 1? So which interval or intervals? Give me one of them. Okay, -infinity to -1/2. Now let's talk about that. We'll come back and we'll see if there's any others. What do we always put at the -infinity side of an interval? Here's the question, and this is why we got a dotted line there, so that we don't accidentally make a mistake. What am I going to put at the -1/2 side of this interval? Why am I putting a parenthesis? You're 1000% right. Because it's not a solution. I just can't see. Somebody over here is speaking, but I can't tell. Thank you. Thanks for waving. I hope you're not offended. So yes, we're going to put a parenthesis here because it's a asymptote. Mr. Perkins, there's an equal sign. Why is it not a bracket? Let me repeat. Because at -1/2, it's not a point of equality. It is a point of undefined. Okay, there's a vertical asymptote there. So that's what reminds me. We good? Because I know there's a lot of details here. It's easy to stumble. So please. Okay, is there another interval where my fraction is less than or equal to 1? Yes, so I'm going to put a union here. So I'm going to join this is all the solution set. So the next one is 1 to infinity. It's this end interval over here. Once again, I always put a parenthesis at infinity. This time, what am I going to put at the 1 side? I'm putting a bracket this time because I erased it, or you can look up on your worksheet, that was a point of equality. And since I have an equal sign here, I need to put a bracket right there. Just for kicks, because we're doing really good on time, maybe down below, or maybe flip to the back of the page. What if I had asked this? What if I had asked, when is x plus 2 over 2x plus 1 greater than or equal to 1? So write down the solution set, the interval for when is this fraction greater than or equal to 1. You don't have to do any new work. That's the good news. You just have to look at our picture. I'm sorry? All I did was change the less than or equal to a greater than or equal to. Okay, this time there's only one interval that's greater than. It's this one in the middle that goes from -1/2 to 1. And the reason I'm asking this is I just want to make sure that you're understanding the reasoning for what we're putting on the ends. That's the purpose for me changing this. There's an equal here. Okay, what am I going to put at the -1/2 side of this? Always, doesn't matter if there's an equal or if there's no equal. There is a vertical asymptote there, so it will be a parenthesis, no matter what. What am I going to put at the one side of this? That's where I have the decision to make. Since I have the equal, that is my point of equality. I'm going to put a bracket. So I've got a half-open interval right there. Before I erase this and we move on to your example that's doing the same sort of thing, is there a question, comment, or concern? Your problem is essentially the same. If you notice, you've already solved the equality up at the top. So just to save a little time and a little work, so I'm going to give you 3 or 4 minutes to go through, do your domain, make your conclusion. And I asked you to actually, if you notice down at the bottom, parenthetically, solve both parts. All right, I'm just going to get started. Again, don't be afraid to interrupt me if there's a question that occurs to you or if you did something different. So step number one in solving an inequality is always to solve the related equation. We did that at the top, and we got that the solution was 2. So the second step is to use a number line to represent the domain. So here's my negative infinity to positive infinity, but we know for a rational equation that I have a problem with the denominator. So I have x plus 2. When is that equal to 0? And that is equal to 0 when x is negative 2. So that's my problem area. So over here at negative 2, I'm going to put mark, and then I'm going to put my vertical asymptote. I have to do that for myself. I would recommend doing that for you. Otherwise, I've made the mistake. If I don't write that asymptote, I will just pretend that that's a point of equality. Okay, so I fumble around sometimes too. I'm going to put the value 2. That is the point of equality. So there's my intervals. I have 3 intervals. And now I am ready. I'm going to go ahead and test each of them, and I'm going to see if each interval is less than -1 or bigger than -1. What do I have where? So it doesn't matter what you tested, as long as you have a number that's properly in this interval, we should come to the same conclusion. So I'm going to use -4. I have no secret reason for picking that. I'm just thinking a lot of you picked -3. So I'm trying to be different to show you we come up with the same thing. So here goes. In the top, I have -4 minus 6. In the bottom, I have -4 plus 2. -4 minus 6 is -10. -4 plus 2 is -2, and that turns out to be 5 when I pop that into my calculator. 5 is bigger than -1, so my first interval is bigger. Between -2 and 2, I'm going to plug in 0 because I'm hoping you picked that. 0 is always the most fun to plug in. 0 minus 6 in the top, 0 plus 2 in the bottom, and I get -6 over 2 or -3 when I test there. So -3 is less than -1. So that's where I put that comparison. And then finally, up here above, I'm going to plug in 4. Again, no secret reason. I'm just thinking a lot of you plugged in 3. And so I'm just trying to be different to show that we get the same conclusion. So 4 minus 6 in the top, 4 plus 2 in the bottom. 4 minus 6 is -2. 4 plus 2 is 6. That's -1/3, and -1/3, that is indeed bigger than -1. Okay, -1/3 is further to the right on the number line than -1, which makes it bigger. So the question that I asked you, firstly, which is right under the exercise 5, is where is this less than? So that happens in one interval. The only less than interval in this example is right here in the middle. That goes from -2 to 2. So I've got that. That's why I like labeling everything. I can see right away what my interval is. So then the question I have to ask myself, what am I going to put at the -2 end? Why am I putting a parenthesis at the -2 end? Asymptote does not matter. We did not look at the sign at all. We don't have to look at the sign to make that conclusion because of the asymptote. What am I going to put at the 2 side of this interval? A parenthesis again. Why this time? Different reason. There's no equals. So you should have -2 to 2 with parentheses at both sides. We okay? I know this is difficult stuff. I know there's a lot of detail. All right, well, then right below the problem, I said, well, once you've done all this work, you might as well solve the other inequality as well. So we're going to solve greater than or equal to. I put that in parentheses down at the bottom. We have 2 intervals of greater than. The first one right here is -infinity to 2. Then we're going to have a union, and the other one is 2 to infinity. We always put parentheses at infinities. I'm not going to insult your intelligence and ask you that question. But this is a -2, sorry. What I do want to ask you, just to make sure it's clear, this is the last time, what are we going to put at the -2 side of this? Parenthesis, because it's an asymptote. What are we going to put at the 2 side of this? We're going to put a bracket this time because there's equals. I am interested in the point of equality. All right, we're almost done. You're doing great. We've got 17 minutes left. I'm just going to change our camera view.
There it is. Okay. So we're going to do the same thing we were just doing, but this time we're just going to use graph. Okay, because every time we've done something, we've also looked at the related graphs. So I'm going to help you plod through the first one, example 4. So example 4 says we're given this fun little graph right here, this rational function, and we are going to find the following. We're going to find where is the function equal to 0, then we're going to find where are the function values less, and then where are the function values greater than 0. Okay, and it could be any value over here. In fact, if we have time when we get through these problems, we'll come back and we'll do this same thing, and I'll change it from a 0 to something else. Okay, so first, looking at the graph. Well, let me ask you, this is a review question. I've asked you this 100 times. F of x. F of x means I'm looking at what values? The y's. So my intervals are going to be the x values that produce these y values. So for the A part, where is this equal to 0? At what x value do I get the y value 0? Looks to me like it's right here where I'm making a dot, right at the x value 1. That's not an interval because it's an equal, so I'm just going to put it as a solution set, 1. Everybody see that so far? Reading graphs, super important. Maybe the most useful skill you get out of this class, if you're not going to take any math beyond it, is being able to read a graph and understand what it's telling you. Okay, the B part says, where are the y values less than 0? So I'm going to trace it with my green pen. Okay, the y values less than 0 are right here. This stuff right here. These are the y values that are less than 0. So I need the interval to describe that. Now let me just give you an addendum. Once again, the website that I use to make these graphs does not draw in the asymptotes for us. So on the test and here, it will be clearly obvious. What is this vertical asymptote right here? What x value is this vertical asymptote, would you guess? 0. Yeah, I'm not gonna make it like 0.5. There will be no fraction. It will be the obvious integer that it's close to. What is the horizontal asymptote, would you guess on this? What y value is the horizontal asymptote? 1. Yeah, okay, so good. You're able to see that. So when you see these graphs on the test, same thing. Okay, so this is I want to know what x values produce these green y values that I've just traced over. So what's the lowest? What's the leftmost x value that produces this green part right here? What's the leftmost x value of this, what I'm tracing with my pen right here? I heard mumbling, but I didn't hear anything distinct. I heard somebody say it, 0. Yep, the leftmost part of that is 0. I really did hear somebody say it. I wasn't just making it up. Okay. This right here, this x value, that's the wall. That's the vertical asymptote. Okay, that's the x value 0. This part of the graph doesn't go any further left than 0. Maybe you didn't see it at first. Do you see it now? What's the furthest right? The y values stay less than 0, meaning below the x-axis. 1. Great. And so now, at the 0 part of this, because there's an asymptote, it's the same reason we put the thing on the problem we just did on the board. I'm going to put a parenthesis there because 0 is the asymptote. And then the conclusion I make at the 1, what am I going to put at the 1 part? Am I interested in the point of equality according to this problem that we're doing right here? No, there's no equals, so I'm going to put a parenthesis there as well. All right, the greater than 0. I'm going to trace this in a different color. It's maroon. I hope it comes through. Actually, for you guys in class, let me change this. I think this will be clearer when I just put it right in the document camera. It's not as fuzzy. Okay, so where is this bigger than 0? I'm going to trace this in maroon. Bigger than 0 means above the x-axis. So that's all this junk right here. And then also over here, this side is stuff that is bigger than 0. The stuff that's above the x-axis, the y values are bigger than 0. So that's 2 intervals for this one. The first interval is all this stuff down here from -infinity. And then what's the right-hand bound of this part that I'm tracing with my pen? Again, 0, the wall, the vertical asymptote, union. And then over here, this part of the interval starts at 1 and continues forever. It never comes back down, so infinity. And again, at the very top, I'm not interested in, I don't know why it says f of x, typo, sorry everybody. And since I copied and pasted, it did it on every problem, so that's professional. All right, so then we will put a parenthesis at the other side as well, because I'm not interested in equality. Okay, so exercise 6 is almost the same thing, just a slightly different function. So if you would please go ahead and do exercise 6 right next door. All right, where on this graph is the point where f of x equals 0? Where does that happen? -4. Yep, -4. Again, you can always be confident. I am not trying to trick you. Whatever value it looks like, when I ask you to read a graph in this class, the values will be integers, okay? So you can rest assured. All right, I'm going to trace the part of the graph that is less than 0, okay, meaning below, meaning the negatives. So that is this part of the graph right here that's now going to be green instead of the red that you were given. And so what is the leftmost bound of that? What's the lowest x value? -4, yeah, when I look left, the leftmost, the lowest x value is -4. What's the furthest right that interval goes? 0, that's where the vertical asymptote is, so 0, yes. And so again, because I don't have equality and because of the asymptote, I'm going to put parentheses at both sides of that. And then where is that greater than 0? Well, it's greater than 0. Let me trace with a different color. Let's see if the purple works better than the maroon. So, whoops, it's going to be over here. And then all of this over here is where it's greater than 0. So for this first interval, the leftmost part of that is -infinity. And then it stops at -4. Union. And then over here, the leftmost part of this part of the curve is 0, that vertical asymptote, and then the rightmost part is infinity. Are we good with those lower and upper bounds? Remember, we're looking, these are the x values that produce these y values that I traced. Okay, so if you have different values, maybe you were looking at the y's. All right, last problem from the day. What I'm going to do is this. I'm going to give you a minute or two to look at exercise 7. And then I've got one instruction for you before you leave. And then what I'm going to ask you to do is this last problem, this review, because graphing is important. That's part of your homework. And I'm going to film a video when you guys clear out, and I'll post it so you can check your work with my work and make sure you're doing this okay. Okay, so that'll be posted when I get out of my second class. So in the meantime, go ahead and do exercise 7, same questions. Yes. Yeah, I've gotten this question twice. That graph has 2 vertical asymptotes. Okay, that we did 2 examples in class. Similar, there are 2 vertical asymptotes there at the obvious integer values. Okay, so that does affect, there are more intervals now on this one. Right, just for time's sake, I know you're probably still working. I'm not meaning to make you feel rushed, but I strive to let you out on time. Where is this equal to 0? Yeah, right here in the middle, at the origin. So at 0, that's the only point where it goes through the axis. And just to clear up any confusion, I know my graphs, be prepared, this is what the graphs on your test are going to look like. There is a vertical asymptote on this side. What's the value of the vertical asymptote over here? -2. I'm just gonna make a dotted line. I'm not gonna go the whole way. I don't want to mess up the graph too much. What's the value of the vertical asymptote on this side right here? +2. Yep. Okay, so there's my vertical asymptotes. So yes, I have more intervals here. So the next question is, where is this less than 0? I'm going to trace it. It's less than 0 on this part of the graph that's green now. And it's less than 0 on this part of the graph that's green. So now I have 2 intervals where it's less than 0. This one right here, what's the leftmost bound? What's the lowest bound of this side right here? -∞. And what's the rightmost bound? Where does this stop being less than 0? At that asymptote, -2, indeed. So I'm not interested in equality, and I'm taking into account asymptotes. So I put parentheses around both sides, union. Then on this part of the graph that I'm now tracing, where does this start being less than 0? 0. And where does it stop? At 2, at that asymptote again. So there's 2 intervals that is less than 0. And the same thing happens for greater than 0. This time I'm going to trace in purple. So tracing in purple, there's this part right here that is bigger than the y value 0. And then there's this part right here. There's 2 parts that are bigger, that the y values are above the x-axis. So on this one right here that I'm tracing, where do these x values start? The x, where do they start? What's the leftmost part? -2, and they end at 0. Union. And then over here, they start being bigger than 0 again at 2. And the x value on this side, as I trace my pen, I can go forever. It'll be infinity. And there is my intervals. Like I said, I'm going to stop the video so you guys can pack up and clear out, and then I'm going to record the video. So please do the graph as part of your homework. That's important. There's going to be 2 or 3 graphings on your test, and I want you to be able to do it well. I hope you have a